Hey everyone, in San Diego. My name is David Dalisay. I live in Washington, D.C. I'm actually a native of California, but I live in D.C. now, and I'm a remote participant for the Zoohackathon in San Diego this year. So, hope you enjoy my presentation, and thank you, Gabe, for putting this event on. So, cheers. Okay, so my project is called Automated Pipelines for Wildlife Trafficking News Articles. So the problem statement that I chose was number 10, and that was about the Wildlife Conservation Society using news articles as an initial step towards understanding what kind of animal trafficking events occur and where and when and how. And so news articles that are relevant to them helps them find patterns with illegal wildlife contraband. And so the problem for that with that though is getting all the data from different news sites is way cumbersome. It takes too long to extract. It's time consuming to structure all that data in a useful way, and deriving all the insights is not immediate, right? So you can imagine taking all the articles listed on just looking at animal trafficking on Google News, and combining all those news sources in a way that's consumable every time you wanted to look something up, which is it takes too long. And so I provided a solution, hopefully that fixes that problem, which is a full end-to-end pipeline that collects news data in an automated way, derives some context about that news data, about data in wildlife trafficking news, such as deriving a particular person's name in that article or particular organizations in that article using natural language processing. And then 3, storing that data in a structured way using Postgres. And then 4, analyzing that data or making data available for analysis in a tool called Apache Superset, which is basically just a dashboarding tool. And I'll go through these steps specifically. Those are the technologies I used, and we'll go through those. So the first one's easy. I wrote a Jupyter notebook, which is just like a UI for Python console, if you don't know what that is. Super easy, super simple. Imagine that you're giving this Jupyter notebook a keyword or keywords, let's say pangolin and scale, and you expect it just to return news articles about pangolins and scales, and it does just that. All you have to do is provide keywords, and it provides you a ton of articles in some date range of when they're published, and it gives you the content, their links, and all, and other derived information. So after we have that information, we can derive interesting context using the data using NLP. So you can imagine that we got every single word off of that last article. I'm going to speed this up a little bit. And then we threw it through the NLP process using a library called Spacey, and it can identify people's names, certain locations, and specific countries listed in that article. So in a couple seconds here, the code, with like 3 lines of code, we're going to see that it actually recognizes the Zoological Society of London as an organization in that article just by looking at the word. And in other words, it can find people's names, it can find dates, it can find countries and things like that. So in that, just through 3 lines of code after looking at that collected news article data, it can identify things that might be useful to someone at Wildlife Conservation Society. And then after that, we can structure that data in Postgres and then make it available through Apache Superset. And it looks like a dashboarding tool. And that's useful because if all the steps up to now were automated, all the members at Wildlife Conservation Society can come into this tool and start asking questions about every article that was ingested automatically. So that doesn't mean just what you see here, which is like the author and the title and the description and the content, which is still very useful. But we can also look at every token, every word in those articles, and see if that derived information, maybe specific people or specific organizations, are talked about when referring to elephants, for example, like in this query, or when referring to rhinos. And it helps the person who wants to do this analysis find patterns when particular wildlife trafficking events are occurring and being talked about in these articles. And this gives the users a way to just slice and dice the data any way they want and not have to worry about all the steps beforehand, the ingestion and the munging through the data. And so with that, I want to talk about just the impacts really very, very quickly. And there's three I want to talk about. One, this solution helps conservation experts at Wildlife Conservation Society just get insights by providing keywords. Nothing else, right? Nice and quick. The second one is the tech I used here was built to collaborate, and it's all open source, so it's easy to stand up. I feel like that's really, really beneficial if we wanted to stand this tool tomorrow, right? And the third one is empowering the users to get to the data analysis faster, right? To get to actionable insights without having to worry about all the steps beforehand, and to find patterns quicker. With that, this is my last slide. Future plans. Hopefully a lot more natural language processing. It would be awesome to try to build into the system a way to summarize articles automatically. Another thing I want to do is put it on AWS, but I need another hackathon for that, right? So hopefully you can get to it, but I'm excited for the future, and let me know if this interests you, and we can exchange code and things like that. Thanks everyone for being patient. I know I've been just this random remote guy, but it's been really fun, and big shout out to Gabe. Thanks for putting this on. Thank you, everyone.